So today we're kind of zooming out and looking at HTTP and the request response cycle and a little bit of what that means for us as Rails developers. The first thing to define here is the internet, and the most straightforward, simple explanation we could come up with probably for the internet is it's a network of devices. And these devices are physically connected somehow. You might have a router in your house that distributes a wireless signal for you to connect to the internet with Wi-Fi, but ultimately these are connected physically. And I'll show that with the next slide. We have wired connections in the form of fiber optic cables and stuff like that. And just to give a visual of what this looks like, this is a map of all the underground internet cables, or underwater, I'm sorry, internet cables that go from continent to continent. So if I'm sending an email to somebody in, I don't know, China, that information has to travel physically somehow through these fiber optic cables underneath the ocean. And this is, you can kind of picture this visual whenever you think about how the internet works on a global scale. Here are some pictures I found on Google of what those fiber optic cables look like at the bottom of the ocean, which I think it just blows my mind to look at these, especially the one that's cut into here, and think about all the, how much information must be shared through these big giant wires at the bottom of the ocean. But then of course, that translates to everything. The internet is physical connections, and these devices connected somehow with different cables and servers and all that good stuff. So this is an exchange of information between devices, and usually happens so that one device requests for information and another device responds with information. When we talk about HTTP, we're looking at a one-to-one relationship, unless something goes wrong, with a request and then a response, something coming back and responding to the request that was initially sent. The requester in this process is called the client. And that would be the device asking for a response. And the server is how we refer to the device that's connected that sends a response to the client. So these are two key words that we'll be using a lot today and beyond. So a client asks a server for information, and a server responds and uses these physical connections to do that. So in order for this process to work, clients and servers need to be able to understand each other, and there needs to be some sort of protocol for them to communicate. And that's where we get Hypertext Transfer Protocol, or HTTP. You may be familiar with HTTPS that's in a lot of URLs that you visit, and that S just stands for secure or security. We won't get into that too much because the process of going from HTTP to HTTPS is obscured away from us for the most part. But it's good to know what HTTP stands for. That's Hypertext Transfer Protocol. And that's just so that these devices can understand the messages that are being sent to each other. So it defines the rules for client and server interaction, and the rules for putting things in the right format and just in packets that the other device will expect. And it ensures that they both understand each other. And breaking this down with kind of some of the terminology that we're introducing, the client is sending an HTTP request and the server is sending back an HTTP response. And what I'd like to do is go to my whiteboard, and we're going to do a little diagram here. Not annotate, one second. Please hold. Okay. This is something that's a little bit more new to me. So if at any point it looks like my drawings aren't showing up or you have questions, please let me know. But there's an analogy that we're going to be using today, and that's the analogy of a pen pal sending a letter and then getting a response letter back. So we can kind of map this to, we can use this metaphor, this analogy, and map it to the interactions in an HTTP request response cycle. So let's say I have, how do I want to do this? This is my house, and this is me. Y'all are really in for a treat with my fabulous art skills today, except not. Okay, so there's a house and there's me, and I have written a letter. And I want to send this letter to a pen pal who's way over here. And we'll say that like my pen pal for this example is Brian. So here's Brian's house. Here's Brian. And then here's a response letter that Brian is going to send at some point. Actually, I'll wait on that piece. So the first thing I have to do is write my letter and then find a way to send it. And I'm going to do that with like a little mailbox or whatever here. I'm going to send the letter, and that's step one. And then the second step is that this letter has to be taken places by the Postal Service, whether that's like with a plane or a truck or, you know, whatever. It's a real fantastic plane that I'm drawing here, right? The idea is it goes from my mailbox and the Postal Service is going to deliver the letter over here. And then the next thing that's going to happen is my pen pal, Brian, is going to open the letter, but then write a response letter to send back. And so the process happens the other way around, right? And now there's a response letter that Brian can send through the Postal Service, and it arrives back at my house, and I can now read this response. Now, I'm just going to take a second to label all the steps in this process. And while I do that, start to maybe think about in your head how we have talked about the HTTP request response cycle so far and how these two things might have some similarities. So let me just throw myself on mute and label these steps, and then we'll talk about it in more detail. I'm going to add in a couple of steps here as we think about this, actually. So instead of just saying send letter, I'm going to differentiate. I'm going to say I'm first going to write the letter. And then the next thing is to drop it in the mailbox. So we'll denote that here. And we have the Postal Service delivering the letter. And we have the pen pal reading the letter. At which point the pen pal can write a response. They know what to respond. So and they have to actually send their response. So we'll say, what is that, step 6? Postal Service delivers, same as before. And then the last step would be, I can actually read the response that I got from my pen pal. Okay, so that's our analogy. I think it pretty much makes sense for today's purposes. And in a second, what I'm going to ask everybody to do is take some HTTP terminology that I'm about to type out here and label their own pen pal diagram with what the terms are analogous to. So I'll type out some of these vocabulary words that I want everybody to be familiar with, and I'll use a different color. Let's do red, I suppose. We'll want to be able to map these examples or these analogies to a client, to a server, to an HTTP request, an HTTP response, and say also just HTTP, what would that represent here? and then internet. Okay, so let's see. All right, I think we're all set here. I think we'll take maybe 10 minutes and I'll give you all the time. I'll just leave this diagram up on the screen to copy down however you want this, like in a, in a digital drawing or in your notebook or whatever. And we're looking to take these terms that I have typed out in red and map them to something in this analogy so that we can kind of understand like what HTTP is doing if we think about it in terms of a pen pal. So I'll throw one in here for free. I'll say that, let's see, which one do we want to say? The person writing the initial letter is going to be this person over here, me in the analogy. This is Brian, this is me. That's going to be the client. So I'll just go ahead and type that in here. Go ahead and take about 10 minutes and think about this analogy and see if you can map these to the different points, and we'll talk about it together. Yeah, like, let's say 1:20. Okay, I know it's not quite 120, but could I get a hand raise reaction if you feel like you want more time to look at this diagram? I think we probably are in a pretty good spot. Okay, cool. So I'm going to, in 1 second, I'm going to call on a couple of people just to share what you had labeled each of these steps with from our list of vocabulary. So let's hear from D. What is the server in this diagram in our pen pal analogy?
I was thinking of the server as the second Brian in your analogy.
Right. So if the person sending the letter is analogous to the client, then the person receiving the letter and sending a response would be analogous to the server. Great, thank you. Cool. Let's call on someone else. Caleb, what would the HTTP request be in this diagram?
Well, I theorized that I don't want to get ahead. So the HTTP request would be the delivering of it, or is that going to be the intranet?
The delivering of it. Do you mean like step 3, the postal service
Yeah.
delivers, and step 7? Yeah. So I wouldn't think of that step as the HTTP request exactly. But what was the other thing you said was your idea?
Dropping in the mailbox.
Yeah. So dropping in the mailbox, that would probably be the step that I would associate with the request. And we can say that maybe the request equals the letter, right? I think that would make sense. So we'll say HTTP request, and I'll put letter here. Cool. Let's hear from Regina. What would be the HTTP response?
Would that be 5?
Yeah, 5, like as far as like the objects that are sketched out here, which piece would it be? Yeah.
So yeah, would it be like, actually I would say 5, but like you'd be reading the response at 8, but like 5 is where it's grabbed.
Yeah.
Correct?
Okay. Yeah, I think that makes sense. So we can put it kind of here between 5 and 6, HTTP response, and that's going to be the response letter, right? Cool. This one's a little bit trickier. Could I get a volunteer to tell me what they think HTTP is in this analogy? Joanna?
Maybe the language in the letter itself.
Yeah, excellent. I think that that's a great way to think of it. And I'll just put this down here. So HTTP is the language the letter is written in. Because if we think about HTTP as this set of rules for clients and servers to communicate with each other, then we can kind of translate that to our human experience. And if I get a letter that's written in Russian and I don't know how to speak it or read it, then I'm going to write back a response and say, hey, please write to me in English. I don't understand you, right? So that could be like where that fits in to the analogy. I'll take one more volunteer for, well, I'll call on somebody for this one, I think. Aaliyah, what would be the internet in this analogy?
The postal service.
Yeah, that makes sense to me too. So I'll put that here in between and I'll just say internet. It's here. Cool. And I think I saw your hand up, Richard. Were you volunteering or did you have a question?
No, yeah, I was going to volunteer. Like in my mind, the HTTP would be both 3 and 7.
3 and 7. Yeah. So I think for this analogy, I can kind of see how that would make sense because HTTP is how the message like kind of gets from one place to the other, but it's really more about the format that the message is written in. And the internet is doing all these things that are obscured away. It might be, if we're sticking with the analogy, it might be a truck or it might be a plane or it might be a boat or whatever the case may be. They might drop it into the mailbox by hand. It might be a PO box, who knows? But those are all things that the postal service, that the internet is doing to deliver things like in those fiber optic cables and stuff. We don't need to know about those low level details, but we do know that in order for the internet to be able to get the letter from here to here, it's got to be an HTTP. Cool. Oh, I thought of another piece here that we could maybe plug into the diagram. I'm going to try to remember what it was real quick. Sorry. No, I think, yeah, this is just kind of like, this is less in line with the lesson plan, but I think it'd be interesting, like as a thought exercise. Can anybody tell me where the computer would fit into this analogy, like the computer that I'm using right now? Or we can also like classify this as the browser that we're using, like Google Chrome, for instance. Lawrence?
I feel like it would be part of 1, 2, and 8 on one side.
Mm-hmm.
Well, maybe not drop in mailbox, but the other request is made by the browser, I'm guessing. So yeah, 1, 2, and 8 on the client, and 4, 5, and 6 on the server.
Yeah, I think what you're getting at is there are a couple of different ways that we could think about this, right? Like, I see a bunch of hands up, so I think people have like thoughts and opinions, which is great. I want to hear those. But let's say for the purposes of this exercise that me and Brian, we'll call these people the users of the computer, the actual pen pal or the people typing things into the browser. And then the HTTP request and the HTTP response are the letters that they're sending, the messages that they're sending. So yeah, let's hear from Susie. What do you think? What would be the computer or the browser in this analogy?
Would it be the truck and the plane?
The truck and the plane? I would think of these as we have it diagrammed as more of the details that we've abstracted away. Like that's how it's actually being delivered across the ocean, maybe, right? Yeah, somebody else just shout things out because there are a lot of hands.
The mailbox?
Yeah, mailbox, I hear a couple, yeah. That's how I think of it too. This is our analogy, so we could say that these things mean whatever we want, but I think this is a helpful way to think of it. So we'll say we'll just say browser, mailbox. Where do I want to put this? Right here. And for further clarification, because if we didn't have this assumption, this could kind of change how we think about things, but we'll say pen pals are the users. So the people using the browsers to send these HTTP requests and responses. Cool. I will go ahead and pause here and take some questions. I see a couple hands up. Regina, did you have a question?
Is the server always, I guess, maybe a person? Could it be like information that's stored somewhere that's like brought back? Or is it, I don't know. Am I thinking of, oh, yeah.
No, that's a good question. And I think, let's see, how do I want to talk about this? Server is a little bit of a general term, and we could use that term server to refer to a lot of things. So I think the most common thing that probably comes to mind, at least it's what comes to my mind, and maybe for you too, is like this big room full of supercomputers, which is like flashing lights and like the CPU towers and like no screens or user interaction, just a big computer that stores a lot of information. And that would be like an accurate description. But we could also, in certain contexts, call our database a server. So it serves up information, it serves up some kind of resource. So in this exact example, we're talking about HTTP requests and responses. The request is something that we're going to send typically through a browser. And we're going to say, hey, I need some stuff. And then the server in some capacity needs to know what to send back. And there are a bunch of different messages that are common in HTTP that we won't get into today, like status codes are a big part of that. That'll be later in the mod that we talk about status codes. They'll send back headers and a body. And the whole idea here is to understand that HTTP is the way that a server and a client communicate. So when we have been working on projects in mod 2 so far and in the intermission work, there's the client that you're going to in Google Chrome and typing in localhost 3000 / whatever. And then when you hit enter, that's going to send an HTTP response It's going to go to a server. And in our case, our server is still on our local machine. So it's going to go to our Rails server and do some things and then send back a response of some kind. Does that answer your question?
Yes, it does. Thank you.
Great, no problem. Susie.
Yeah, I have like a follow-up clarifying question
Sure.
from your answer to Regina's question, but in this example, the HTTP response isn't the thing, it is the product of whatever wrote the response, right? So for 5, is that technically the server doing the action of writing the response?
Yeah, so we could maybe think about this in a different way where instead of like if we're, let me think about this. Server could mean like some code that we've written that knows how to respond to that particular kind of request. That code would live on the server. And I've been talking a lot about this in terms of like our own project, but yeah, you could think about this as, this is something that exists somewhere else that knows how to respond to your HTTP request. Typically like a web application. There's a lot more to it than all that. This is a pretty like high level example, but yeah, you can think of a server as like a resource or maybe like another person who has written that code. You could, because I think one thing that could be confusing about this diagram is we could think about this like, oh, this is an end user, this is an end user. Oh, I can't edit my text here. But really in most cases, the server is gonna have some kind of pre-configured response to send back. I hope that gets to what you were asking. Can I clarify any further?
I guess I was just curious in terms of like responsibility for both sides. Like the client would write the HTTP request and then would also read the response, right? That is the responsibility under what a client would do. And then in this case, if the person who's on the other end of that is not another user, but it's just like the database, right? The database will always be responsible for reading and responding to that request. Like it does, okay. It would never just like read it and just say, I read it, right? Like it would always respond.
There's always some kind of response. Something would have to go pretty wrong to not get a response at all. The one clarification I'll make, let me think, what was I gonna say here? We're thinking of the person, the actual pen pal is a user, and then the mailbox is what makes it possible to send that request or send that response. So in our exact analogy, this pen pal over here would more than likely really be like the existing code or the person who wrote the code that knows how to put the response in the mailbox. I hope that clarifies it.
Yeah, that does. Yeah.
Cool, great. Yeah, we have no problem. We have one person like writing up an HTTP request with the means of a browser. And then the browser is what actually is the entry point to this HTTP request response cycle where the request is sent. And then this browser or this server or whatever entry point to the server on that side is responsible for reading the request and then throwing together a response. So it might not be as human on this side, but just for the sake of the analogy, right? This whole area here is the server, reads the letter, writes a response, puts it back into something that the browser can understand using HTTP and sending the HTTP response back with the internet, where the browser can then interpret that response and allow the user to read it with human eyes. Cool. So yeah, not like not perfect illustrations, not a perfect analogy, but hopefully gives you all a way to like just think about HTTP in more like concrete terms as far as like how the messages are going back and forth and kind of what the order of operations is. I'm going to go ahead and save this diagram and I will post it in the code help channel. Give me 1 second to do that before I forget. Is that the right one? No. Okay, I think that is sent. Cool. So in case you need that for your notes. Any other questions before we move on about just how the HTTP request response cycle works at a high level? Cool. This is a little bit like abstract and theoretical compared to like the stuff you're doing in the project right now, but it is really good foundational information because it'll be really important to understand kind of the language and the protocols that we're working in and around as we build out our Rails apps. Even when some of this is abstracted away in Rails, it's important to know about HTTP and just how it works at a very basic level so that we can like use that for debugging and stuff like that. So let's move on. I'm going to open my slides back up here. Maybe. Sorry, I closed out my window with the slides. Give me a second. Okay. So just to kind of recap what we saw in our diagram, clients were sending requests and servers sending responses is called the HTTP request response cycle. I think that these are probably the biggest pieces of vocabulary I'd encourage you all to like write down or really try and memorize. And in mod 2, we'll be writing server-side code. So we talked about how in our examples on localhost, we are using both the client and the server in kind of a weird way. If we're using Rails S and going to our development environment and interacting with the site as a user would, we're acting as the client. And then the code that we write that is served up to package up HTTP responses and show resources to the user and stuff like that, that's our code acting as the server. And it's important to have this understanding of HTTP because our code has one job: receive an HTTP request and send a response. And we do need to know at some level how to interpret requests, maybe not all the finer details, but the basics, because it's just kind of how we speak on the internet and how our servers and how our apps communicate. And if we can interpret requests, we should also know how to send responses. And like I said, Rails takes care of some of this for us, but when things go wrong, it's really valuable to have that background knowledge to be able to troubleshoot appropriately. So next we'll take a little bit of time. Let's see, 1:35. I think what I'd like to do is try to power through a little bit of reading and discussion and maybe wrap up class a few minutes early. So there is a lesson linked in the calendar event, and it's the How the Web Works lesson here. And I'd like to give you all about 10 minutes to read this section. So reading from where it starts is the HTTP requests and responses section. And you would stop at the checks for understanding. And then we'll come back together and discuss some of these concepts as a group. Alex?
Yeah, really quickly, I was just trying to connect this stuff to the work that we're doing right now. And so when we're thinking about like the request and response, is it really off, or is it kind of on track to think about it with like get being the request and then post being the response? I also think that maybe we're about to read about that, so I might say never mind.
That's okay. No, I think you're on a good track. That's pretty close. I wouldn't necessarily say that post has to do with a response and get has to do with a request exclusively, but the verbs that you're talking about, like get and post, are very relevant to how we handle HTTP requests and how we craft responses. So yeah, I'll give you all a few minutes to read through this. I think it might explain a little bit about what you're asking about, and then we'll dig a little deeper after that. Let's come back together at 1:42. And if you want to build in a POM, if you read fast and you want to build in a POM, that's fine. We'll come back at 1:42. All right. Sorry about that switching around, but let's come on back together and let's go through these checks for understanding. So I'd like to take a brave volunteer to describe the HTTP request and response cycle and do your best to use all the terms that we introduced today that are bullet pointed here. Could I get somebody to raise their hand and volunteer for that? Cool. Molly.
Sure. Yeah. So the way that it works is that the user would enter a URL or enter something into type something into their browser. The browser would build the HTTP request and it would address that to the server or at that address for the URL. And then the server would build the HTTP response, send that back through the internet to the client, which would read that HTTP response and then provide information back to the user.
Awesome. Yep, that was really great. That's pretty accurate. I think we could have also, maybe I missed if you said client in the beginning, like where the user is using a client to send an HTTP request to the server. But yeah, no, overall, that's very accurate. That was good. So another thing that kind of brings up as I'm thinking about that is how often we're actually doing these HTTP requests and responses. So if I go to google.com and I push enter, that is one request and response. And then if I type some stuff in here and I push enter, that's another request and response. And then if I click on, I don't know, maps, then that is another request and response. So this may be happening in real time very, very quickly and over again at any given point as a user interacts with our application. So cool, that's great. Let me think about this for a little bit. Yeah, I'll just leave this page up and I'll ask somebody to tell me what a path is. And I'll just take a volunteer for that as well. Joe?
The path is the URL, I believe. So you're doing google.com and then you're going into maps and then it's going in the search and searching this randomness that you typed in, which is giving you the next piece of the path.
Yeah,
I believe.
Yeah, that's pretty close. So I will clarify and say that, let's see, what can we go to? Module 2. Yeah, that works. So the path would not include this first part, what we call, we'll get into this in another lesson, but this part is called the domain. The path or the URI, which are synonyms, would be everything after the first slash. Thank you, Joe. What is a verb? I'll take a volunteer for that. Lawrence, I saw your hand up. Can I call on you? For what is a verb? I'll go with Alex.
Yeah, a verb is what says like how the information is being requested from the server, right?
Right. Yeah.
Okay.
Could you give me an example of some verbs we might see?
Yes, we can see the 5 common HTTP verbs are get, post, put, patch, and delete.
There we go. Awesome. Thank you.
Apologies, I didn't realize I was muted there.
Oh, my bad. I didn't see you if you were talking. But no, thank you. That's fine. Cool. So does anybody want to speak to what these 5 common HTTP verbs do? And I'm going to click away from the answers just to give somebody a chance to practice talking about it. Go for it, Alex. What do they do?
Yeah, so get, I think, retrieves, or not retrieves, but like, yeah, takes a piece of information, retrieves a piece of information. I think post creates a new place for information. And then, oh yeah, so put changes the entire, the entire like spot. It says resource, but yeah, so entire resource. And then patch only changes a specific portion of that resource of information. And then delete is destroying the, like taking removing the piece of information.
Yeah, that's great. Thank you. Kevin, I saw your hand up. Do you have anything to add to that? Maybe like going more into the difference between put and patch, for instance? That might be an interesting one.
Not really for that one. Just
Okay.
going back to the general functions. I think most of the time when we send requests, we're retrieving information like the destination, like an index or a show page of something. When we create, it's usually like a form where we can fill in the different attributes, and we'll create a new instance or object. So you're asking about put versus patch.
Yeah, that was my original question, but you actually said something I'd like to take and run with. Thank you.
And then kind of along the same lines, as you create a new resource or new object, you can edit an existing object or delete it. And yeah, and put, it seems like yeah, I don't know what the criteria is except that put I don't know if you would override an existing attribute or you necessarily have to change it to something new, but a patch is you can change maybe one attribute versus the whole thing. But
yep, that's great. Thank you, Kevin. Yeah, and I think you both, Alex and Kevin, you both got to a good point on the put and the patch. I think that one's kind of confusing, but really the difference would be that a patch is just updating a part of a resource, and you would specify which part in the request. So you could see that being like maybe the description of a task instead of updating the entire task record. And a put would update everything. So you would need to include everything you wanted that resource updated with in a put. We won't use put very much. It's good to know about it, but usually we're going to be looking for patch when we do CRUD and we are using an update. The other thing I want to speak to, Alex, that you said with the post, I think you mentioned something along the lines of it creates like a new space for a resource, or it creates the place that something's going to be stored. A post is really going to create that new resource. It's going to create a record. So that's just like a small distinction there. I see a couple hands up. Caleb, do you have a question?
Yeah. With the put, it seems a little unwieldy. Could you give like a use case for a put, just for like fun, I guess?
Yeah, theoretically, I could see it being useful where maybe I have old information in a database and I'm doing a big data migration and I have to update all these users, and all the users have like they're inactive users. So I want to change all their usernames to their original username plus dash inactive. And I want to change the updated at to today. And those are the only fields, and I want to do it to a bunch of them in the database. A put might be more useful because I'm updating the whole resource anyway, right? I don't think it'll be immediately applicable to anything we're doing in mod 2.
Thank you.
No problem. Kevin, something else, another question?
Yeah, kind of specific question.
Sure.
Actually, so you're saying when in that case, that example you gave, the resource is the whole, if you're updating every username, is the resource the whole table, or is the resource a single object?
That's a good question. I would still tend to think of a resource as a single object, but I think it would depend upon the context. I guess you could say something like, yeah, I don't know. I would just look for contextual clues, because resource could be used interchangeably with like table, but it could also be, oh, I'm updating this resource. And that context would make me think of a record. So resource is a more generic term, I would say, and record specifically means like this one thing, and table specifically means this collection of related data. Is that helpful?
Yeah, no, that is. I had a kind of specific question for put versus patch. Let's say you're doing an edit form where you put in the default, you show the previous name, or the previous username was blah blah without the dash, and but all the other fields had the defaults filled in, and then you enter just the dash into the username and you submit it. With the defaults in the other fields, would that make it a full put? Because will it rewrite the previous values with the default again? Or I guess it's more related to how the default value works in that case. But would that be a patch because it's really only changing the username, the dash, or is it a put because it's overriding everything with the default in the rest of the fields, if that makes sense?
Yeah, it kind of does. I wish we had an example to look at to kind of walk through the whole process with the form, but I think that's probably That's probably something that we'll get into later in the mod anyway. What I would say is you could probably do it either way. It just depends upon, excuse me, how you write your code to build that response. You could say, you could basically tell it to update everything that had changed from the old record if this was an update. And that would be a patch. It would just update the things that were changed. Or you could say, hey, take all these fields, no matter what they are, and update with these fields. So you could do it either way. I think typically still, I just reach for a patch. It's hard for me to justify using a put when we don't really need to overwrite everything. Cool. Any follow-up questions to any of that before we finish up with these slides? Okay. Thank you all for asking so many great questions. It's really good to have like conversation and talk about these things, especially with like such an abstract lesson and not a lot of code. So keep them coming. To finish this off, I think we'll talk about the different parts of a URL, just a couple more slides here, and then we will call it good. Let's see. Yep. So here's an example URL that we can look at, and these are just like the pieces we can break it up into. So the first piece is the protocol. This is HTTP. When we're sending requests in the browser, there are ways other than the browser to send a request, but that's because it's the context we have. We're mostly focusing on the browser today. And this is what you would prefix it with to say, hey, this is an HTTP request. So pretty standard in every URL you'll type into your browser. The domain, like I mentioned before, would be this main part of the URL, which goes up to this first slash after the protocol. Like here we have these slashes that are part of the protocol, but then we have our domain, in this case, task-manager.herokuapp.com. And then after that, we have the URI or the path, which are the same thing. And that's everything after the slash. But for the purpose of like our example today, we have something kind of special in the URI that's called the query string. So the query string would start with a question mark, and we'll get into this in later lessons, but the key value pairs that you pass after a query string will be available to you in the controller. I don't want to get too into the weeds there, but just to be able to identify it when you look at a URL, if you see a question mark somewhere in the URI, if you see this question mark in the path and like key value pairs, that is a query string. I forgot to mention that URI stands for Uniform Resource Identifier. So a URL is this whole thing, including the domain, the protocol, everything, and the URI is just everything after the first slash. And then in some cases, you might also see something called an anchor that's denoted with this octothorpe or hashtag or whatever you want to call it. And this is basically like something we can give our URI to say, hey, scroll to this part of the HTML on the page. So you can actually include in your URI a way to jump to a particular part of the page that you're going to. Query string and anchor, I think for now are just nice to know, little tidbits of information. You might find them useful later on, but the real key knowledge here is the protocol, the domain, and the path or the URI. And for the sake of time, I'm just scrolling through these a little quicker. So an HTTP request is going to include a URI or a path. It'll indicate what you're trying to access. In this example, we have accessing all tasks or accessing a specific task. This is denoted in the URI or the path. And the HTTP request will also include a verb. So a get would be for retrieving, a post for creating, patch and put both have to do with updating, and then delete maps to destroy. Cool, Mark.
Just a quick question. The query string and the anchor, is that part of the path as well?
Yeah, I would consider it part of the path. Technically, they're also their own thing, but really the URI is anything after that first slash after the domain. So I'm open to being corrected, but yeah, I believe that's also considered part of the path.
Thanks.
Mm-hmm. Cool. Any other questions before we wrap up? Awesome. Well, thank you for hanging in there today. This is Again, it's a little bit of an abstract lesson. It's okay if it doesn't all quite make sense yet, but it is really useful background information before we jump into the nitty gritty of putting together our routes and accepting HTTP requests and all that good stuff. So yeah, Jennifer.
I have an off-topic question, if it's okay.
Absolutely, let's hear it.
What is the benefit of using Rails console versus Postico?
That's a good question. The first thing I'll say is that not every place that you'll be using Rails is going to make use of Postico or even Postgres. When you're using Postico, you're getting a visual representation of what's going on in Postgres, what's going on in your database, and with that particular database management system. Rails console is going to load up your whole development environment, your whole application, including your models, all the data that you have in your database, and you'll be able to interact with it using Ruby, but more specifically using Active Record. So remember in our class earlier today, we talked about how Active Record is database agnostic. You can plug it into any database and still use your nice Ruby objects that it gives you. That would be the advantage. The primary advantage being that you would be able to interact with your data using Active Record, but then also you don't run the risk of changing things in Postico, for example, and then having sequential ID issues like we talked about in class earlier. So Postico is really nice for getting a visual of what's going on and like a representation of your database and the data that's stored in it, but it's really better practice to use Rails console, especially if you want to work with nice, easy, pretty Ruby objects. Is that helpful?
Thank you.
No problem. Okay, I think that is it. I'm pretty sure the rest of today is work time and PD. So I will let you all get out of here. Thank you very much and see you tomorrow.
Thank you.